NASA officials asking the Chinese for help in planning an American mission to the far side of the moon.
It was just soil, less than 4 pounds of dust and rock in a sealed metal pod. But inside, that silence was something Earth had never touched before. A chemical fingerprint from the far side of the moon. And it didn't match anything we thought we knew.
More than 50 years later, though, there's still a lot that we don't know, or things that we thought we knew that aren't quite so clear-cut.
So buckle up as we descend into the shadowed hemisphere that has defied exploration for over half a century. A place where silence is not absence, but armor. This is the forbidden face of the moon. The forbidden hemisphere. For as long as humans have looked up, the moon has offered a familiar face, cratered, stoic, always turned toward us. But that familiarity is a trick of orbit. The moon is tidally locked, rotating once per revolution around Earth, which means one hemisphere never turns to meet us. And for decades, that far side was more than a blank space on a map. It was untouchable. From the start of the space age, engineers and astronauts knew that landing there meant courting disaster. The far side isn't just distant, it's silent. No radio waves from Earth can reach it directly. Without a relay, a rover or lander would be deaf, mute, and alone. Unreachable if anything went wrong. That's why Apollo crews never tried. It's why the Soviet Union's lunar missions stopped short. The far side became a myth of limitation. Unreachable not for lack of fuel, but for lack of connection. Then, in 2018, China quietly began to solve the silence. A satellite named Magpie Bridge Berger was placed beyond the moon in a gravitational balance point where it could see both Earth and the far side at once. It was the first real whisper across the void. And in 2024, that whisper became a voice, as Chang'e 6 set out to land on ground no one had ever touched. A machine without a lifeline. May 2024. A small lander detached from its orbiter and began falling toward a jagged wound on the moon, the South Pole Aitken Basin, one of the oldest and deepest impact scars in the solar system. Spanning 2,500 kilometers wide and plunging up to 8 kilometers deep, this was no gentle valley. It was an ancient battlefield carved by violence older than Earth's continents. For 15 minutes, Earth went silent. No joystick, no last-minute corrections. Chang'e 6 was alone, descending into shadows and uncertainty. Every signal from Earth would arrive too late. The spacecraft had to survive on its own instincts. A synthetic mind trained to navigate death traps in real time. Its cameras scanned for danger. Boulders the size of trucks, steep slopes, uneven terrain. Dust erupted beneath its thrusters, blinding sensors. Gravity pulled harder. The AI adjusted thrust, rotated the craft, rejected unsafe zones, recalculated every second. Fuel burned with no backup plan. Then, contact. The legs flexed, the engines cut, the machine held. Against every odds charted decades before, the far side had been touched. But the landing was just survival. The real question lay beneath its feet. The sample that didn't belong. 53 days later, a scorched capsule slammed through Earth's atmosphere and landed in Inner Mongolia. Inside was a payload no one had ever seen before. 1,935 grams of rock and soil, extracted from a part of the moon that sunlight barely reaches. The container hissed open in a sterilized lab. What scientists found wasn't what they expected. It was darker. Apollo samples from the near side were pale, chalky, dusted with familiar basalt and powdered lava plains. But these new fragments carried deeper tones, ash black, iron rich, with specks of glass and mineral that didn't fit the near side story. The chemistry was immediately strange. The isotopes whispered of colder lavas, buried crust, and something else. Hints of materials pushed up from far beneath the surface. It didn't make sense. The moon was supposed to be uniform. One body, one history, a globe of cooling rock. But now, the evidence defied that. This was not just a different location. It was a different world entirely. The moon, it seemed, had two faces, and one of them had been hiding more than its light. So where had this darker soil really come from? the moon that melted, then froze unevenly. Billions of years ago, the moon wasn't gray or solid, or even a sphere as we know it. It was molten, a seething ocean of magma born from a cataclysmic impact, when a Mars-sized body called Theia struck the early Earth and hurled debris into orbit. That debris coalesced, glowed, and churned until minerals began to separate. The dense ones sank. The lighter ones rose like foam on a boiling pot. Eventually, the moon froze into a crust, bright, jagged, ancient. But it didn't cool evenly. On the near side, the crust is thin, around 40 kilometers. Lava pushed through, erupting again and again to form dark Maria plains that make up the face we know. But on the far side, the crust is thick, closer to 60 kilometers, forming rugged highlands that lava couldn't breach. For decades, scientists could only guess at why. Then, in 2022, NASA's Lunar Reconnaissance Orbiter detected something astonishing. Anomalously low concentrations of thorium and potassium on the far side, heat-producing elements essential for keeping a planetary interior warm. The far side, it turned out, wasn't just thicker. It was colder, quieter. It had shut down early. That one revelation cracked open the moon's symmetry. Its hemispheres had followed different fates. One held onto its inner fire. The other let it go. But if the moon evolved like two planets fused into one, what else was forged in that fracture? Impact physics and the carbon mystery. To the naked eye, lunar soil is lifeless, a fine gray dust born of stone and silence. But under an electron microscope, that illusion shatters. In the samples returned by Chang'e 6, scientists found something Earth usually creates only in high-tech labs. Graphene, not graphite, not soot. Actual few-layer graphene. Carbon atoms arranged in ultra-thin sheets only 2 to 7 layers thick, strong enough to stop bullets, light enough to float, and electrically brilliant. On Earth, we manufacture it with heat, pressure, and precision. On the moon, it forms through violence. How? Micrometeoroids, tiny grains of rock traveling at tens of thousands of kilometers per hour, strike the surface with unimaginable force. No atmosphere softens the blow. In a fraction of a second, the impact unleashes shockwaves so intense they can rearrange carbon atoms, forge new molecular structures, and then lock them in place as the energy dissipates. Some fragments even showed carbon shells wrapped around mineral grains, tiny carbon cages born not from life, but from chaos. This wasn't contamination. It wasn't accident. It was a process. The moon, in its silence, had become an accidental factory, forging materials we once thought required industrial civilization. If graphene is hiding in dust, what other tools might nature have already built in the shadows? Water, scarcity, and the settlement equation. The moon was never supposed to have water. For decades, textbooks labeled it bone dry, a lifeless desert of rock. But Chang'e missions, along with others, began to tell a different story. Not of rivers or lakes, but of droplets, trapped in the most unexpected places. In 2020, a sample from Chang'e 5 revealed a hydrated salt, ammonium magnesium chloride hexahydrate, NH4Mg3 carrying an astonishing 41% water by weight. Meanwhile, a 2023 study in Nature Geoscience found that tiny glass beads formed by ancient impacts could also hold water. Solar wind hydrogen, slamming into the moon, bonds with oxygen in the glass, creating molecules that remain sealed inside. It was a revelation. Water didn't need to flow or freeze. It could hide, locked in crystalline glass, waiting for heat and pressure to release it. A new strategy emerged. Not importing water, but extracting it. Heat the beads, capture the steam, harvest hydration from silence. But there was a twist. Early analysis of the far side samples revealed something troubling: dryness. Less than 1.5 micrograms of water per gram. Far less than near-side collections. Suddenly, geography became strategy. Not every landing site would support life. Survival on the moon wouldn't depend on rockets or suits. It would depend on location. And not every crater would offer mercy. From footprints to factories. In the 1960s, the moon was a trophy, a place to plant flags and vanish. Today, It's something else entirely. Infrastructure. NASA has mapped 13 candidate landing zones near the lunar South Pole for Artemis III. Each is chosen not for beauty, but for sunlight and shadows. Sunlight to power machines, shadows to trap ancient ice. Meanwhile, China's roadmap accelerates. Chang'e 7 and 8 are designed to scout, drill, and simulate living off the land. Their target? The same polar region, home to Shackleton Crater, where peaks stay sunlit for months and the depths never see light. But it's not just about water anymore. The regolith itself is becoming a resource. Within it lies helium-3, a rare isotope theorized as future fusion fuel. China's Chang'e 5 even discovered a new lunar mineral, Chang'e. Why? Containing trace amounts of it. The catch? Helium-3 is vanishingly rare, measured in parts per billion. To harvest enough, we'd need to turn entire landscapes into processing fields. So, the moon becomes a supply chain, an outpost not for explorers, but for engineers. What was once sacred terrain is now surveyed, zoned, and modeled for industry. The new race isn't for first steps, it's for first claims. So, the moon wasn't uniform. It was divided from the start. One side burned and bled, the other sealed its history in silence. Now that silence is breaking. Should we mine its dust or protect what might never return? Drop your thoughts in the comments. And if you're chasing the next clue, hit subscribe. The far side is just getting started.